Hi, I'm Bob Tabor with Developer University. In this video, we'll learn about Linq, L-I-N-Q, for filtering, sorting, and performing other group-related functions on collections like we just learned about in the previous lesson. So Linq stands for Language Integrated Query, and it comes in two forms, and we'll look at both of those in this lesson. There's, first of all, the query syntax itself, which resembles SQL, the structured query language. So if you're already familiar with SQL, you will see some similarities and will help your adoption of Linq. But there's also, in addition to the query syntax, there's a method syntax. So it's just calling a series of methods just like you would any other method, and you can chain those methods together like we learned about previously. Now the only little wrinkle here is that they use a special feature of Visual Basic called lambda expressions, which are these like mini tiny functions that you pass in as a parameter argument into those methods, and that can sometimes bend your mind a little bit if you're not familiar with looking at them. But we'll take a look at them, and I'll try to explain what each of the little lambda expressions do for us. And I'm only going to show a few examples of Linq in this lesson. Frankly, you could create a whole course just around using Linq inside of your applications just to demonstrate all the features of Linq. So it's a pretty extensive topic. To get started for this lesson and introducing Linq, I want to grab the source code for this lesson from the before folder, and I'm going to copy that and put it into my projects directory. And we'll paste it there. Great. Now let's open that up. And if you take a moment to catch up with me, you will be looking at the same thing I'm looking at right now. As you can see, I have a car class. It has make, model, year, and sticker price. And then I'm creating a new list of car, creating several cars using that object and collection initializer syntax to create 5 cars so that we can start filtering and sorting these cars and displaying them on screen. Okay, so first of all, let's just take a look at how to do a simple query syntax for to find all of the cars that are from BMW. So let's go dim BMWs equals from car in my cars, which is the name of the collection, as you can see here. Then where car.make equals BMW, select car. Okay? And then here what we'll do is just do a for each item as car in BMWs. And we'll just do console.writeLine. And here we'll just make it easy. We'll go use the replacement syntax and just use item.make, item.model, and item.stickerprice. And we'll go ahead and just format the sticker price. All right, so let's run the application, and we'll see now that we get from our Linq query only 3 BMWs out of the possible 5 cars on our car lot, and we're also displaying the model and the price. Awesome. Okay, so that's a simple case where we're just looking for and filtering by a single property of the objects inside of our collection. Let's go and make this a little more advanced. In fact, I'm just going to copy the previous example, paste it here, and we're going to say that this is almost identical, but instead of just filtering on one of the properties, I'm going to filter on 2 properties and find those BMWs that were created in the year 2010. All right, so what I want to do is just to add another item here, and we'll go item.year. Okay, And so now let's save it and run it. And we can only find one BMW that is a 2010 model in our list of cars. All right. So by using the AND keyword, we're able to add additional filtering criteria in our link query. All right. All right. So far, so good. What if we look for just those newer cars? So let's start off by going dim new cars equals from car in my cars, where the car.year is greater than 2009. Let's just go ahead, first of all, and just select the car itself. And then we'll come back and do this a little bit different the next time through. I'm going to change this from BMW, since we changed the name of the collection we're retrieving back, to new cars. All right. And so let's run the application, and you can see now we get 2 cars back that were newer than 2009. And now let's go one step further and say we only want to select out certain attributes. So instead of select car, let's select just a couple of attributes and put them into a new data type. So car.make and car.model. And those are the only 2 attributes that we're going to use. Now, already you can see that we've got a small issue here. When I added this select new with, it doesn't like it here because I'm no longer working with a collection of cars. I'm working with a collection of something that resembles a car because it has 2 similar properties, but this data type that I'm actually creating here on the fly, it will only have 2 attributes, a make and a model. In other words, I'm creating a new data type. I'm projecting the data from car into a new data type. What's the name of the data type? I have no idea. We're just making it up as we go along. It has no name. It's anonymous. So we're creating or projecting out only a couple of properties from our query into a new anonymous data type, a class that we're creating on the fly that has no name. Now internally, Visual Basic will give it a name. So that's one of the problems here that we see, that we are, instead of working with a collection of cars, we're working with a collection of something called prime A, the little dash in the A. So all you need to know about this is we're just going to remove this as car part here, and it should work. Now, you'll see that we're going to get some more errors. Why? Because this new anonymous data type doesn't have the idea or any definition for a sticker price or a year. So we're going to need to delete those attributes as well. But now that I've done that, whoops. Okay, we got to also remove the replacement syntax here associated with it, and now we can run this. There we go. So I realize that I threw a lot at you in that little code example, but just reason with me here. If I don't need to pull back all of the data, and because I only want to display just a few properties of the data, then selecting the entire object out of the collection and putting it into a new collection might make that new collection just as large as the old collection. So I can be a little bit more savvy about only choosing those attributes that I really need and putting them into a new anonymous type. Now, you may never do this. I just wanted to show you what was possible. All right, so again, this is called projection, and we're projecting into an anonymous type in this example. But there were some ramifications from it. It was a little more complex, and I don't want to throw you too much, so let's just move on from there. And let's talk about, instead of filtering and projection, let's look at how to order, and this will be a simpler example. So ordered cars equals from car in my cars, order by car.year, and then select car. All right. And so let's just call this ordered cars. And then let's also add back in item.year. And let's go ahead, add back in the as car. And let's go ahead and run it. And so we should see a list of all 5 cars. And let's also add back in the display of the year so we can see that. All right, so now we're going in order from the oldest to the newest. So what if I wanted to actually sort them in the opposite fashion? I can order by descending. There we go. And now when we run it, it will start with the newest cars and go to the oldest cars. Great. All right, so we saw a few examples of the query syntax, and I didn't emphasize it at the time, but if you are familiar with the structured query syntax, things are in a little bit different order. Like, for example, in a structured query language syntax, you would see the select first and not last. However, the syntax is close enough that you can easily adapt your thinking to remember it and fumble your way through with the help of IntelliSense. All right, so let's start back over and remake a few of these examples, except not using the query syntax, but rather the method syntax. So here we go. Let's start with just finding all BMWs. So let's go dim BMWs equals my cars dot. So look, we're already using, instead of we're using methods instead of using a syntax that looks like SQL. So here's where things get a little funky, right? I'm going to have to find all cars that, what was the criteria again here? That are BMW. Okay, so here what I'm going to do is pass in what's called a lambda expression, which is a mini method or a mini function. So I'm going to say the criteria we're going to use for the where clause is I'm going to create a little function and I'm going to pass in each car in my list of cars. And I want you to pass me back those cars where the make is equal to BMW. All right, see how we did that? So again, just think of this as a mini method. I'm not going to give the method a name. I'm just going to say, I'm going to pass you in every car in my list of cars. You pass me back all of the cars that match this function's body, the criteria that I'm defining here, where the make is equal to BMW. All right, and then at that point, we'll be able to then iterate through and look at each of the cars inside of that collection that we're getting back from the where clause. So run the application, and we get back all BMWs. All right. So what if I wanted to extend this and say, not only do I want you to give me back all BMWs, but also all BMWs, and we'll do the same sort of thing, where, so I'm just chaining on another method, another where clause here, and I'm going to pass in another little lambda expression, another little mini method. So function, and I'm going to pass you back, of all the cars that were passed back whenever we eliminated some from being just BMWs, now we're going to further refine that, and we're going to pass in each of those cars into this little mini function and say only return back those cars where the year is 2010. All right, so we're going to filter the original list, and then we're going to filter the list that came out of that, and then return back that list, and then we're going to iterate through each of the items. I think there's only one item that meets that criteria, a 2010 550i. Okay, great. All right, so now let's take a look at the ordering of cars. So let's go dim ordered cars equals my cars dot order by descending. So there's a whole method just for order by. We'll start off with the order by or order by descending. So here again, I'm going to say, I'm going to pass in a little mini method to tell you what I want to order each car by, and I'm going to want you to order it by the year. All right, so let's go ahead and change this to ordered cars. And furthermore, I think we can, print out the year. Great. All right, so we've ordered them from oldest to newest, and then we can do the order by descending to create from newest to oldest. Great. Now, I personally prefer the method syntax. Once you get past what a lambda expression really is, once you can like rectify that in your mind, and you can look at examples online for help for a given link extension method, which are these wheres and orders and order by. Those are extension methods that are added onto collections by the link functionality. Then I think it's the easier syntax, frankly. And you can do some interesting things with a little bit less code. So one of the things that I want to show is, in fact, let's go ahead and comment that out. You can perform operations on the entire group as a whole. So say, for example, I wanted to get the total of all the cars on my car lot, their total value. So I might do something like this: dim the sum, and I'll go my cars dot, and notice here that there's a sum method, and I'm going to say, and give it one of the mini functions, passing in every car from the list of cars. I'm going to say sum it by the car sticker price. So go through every car and add up the sticker price and then return back the total amount for me. And here we'll go console.writeLine, and we'll put in the sum, and here we'll say total value and 0C to format it like currency. And the total value of all the cars on my car lot are $250,000. Cool. Let's take a look at some of the other method syntax options that we have. So for example, we can aggregate items. We can get an average of, for example, each car's value. We can cast or convert each object from one type to another. We can get we can find out if an item exists in our collection, and we can find the first item or the last item. We can do the for each, which will be pretty cool. We can group by items just like we could in SQL. We can get the max and the min. We can do even complex unions between two data sets. So it can get pretty hairy, but let me just show you one other thing just so you're aware of it. I want to use the for each, and what I want to do is actually take every car and add $10,000. We're going to have the opposite of a sale. So instead of a function, I'm going to pass in a sub because I don't want anything to be returned back. I just want to operate on each item inside of each item that we pass in. So each car in my cars, I want to take the car and add $10,000 to the sticker price. And let me do this. So sticker price, let's do plus equals 10,000. All right, and then let's go ahead and print out and get a sum of all the cars, and then print that out here. And let's see what we come up with. There we go. All right, so there we go. We have increased the value of our car lot by 50,000. Why? Because we've added 10,000 to each of the individual cars. In fact, I could even make this a little bit shorter by just going here with the total value. Let's just go mycars.sum. We can do it right here in line. And function car, and inside of that, we'll do car.stickerprice. All right, so we're able to reduce that down to 2 lines of code, but I'll bet you I could even reduce this down to 1 line of code. Let's do inside of this, we can get pretty silly here and do sticker price plus 10,000. Let's see if that'll work. Here, I'm gonna get rid of that. And it's not a permanent change, but we're able to do it all in 1 line of code. You can see how crazy this gets. Let's go ahead and split that up into multiple lines here, just so you can kind of see it all. not sure what the right way to be split that out, but there you go. So we can get pretty crazy with this and do some really interesting things, all in a very compact syntax. It makes your code less readable, but you can do some powerful querying, filtering, sorting, and also group operations on your data with using LINQ, both the query syntax and the method syntax. All right. So that's really all I wanted to show you in this lesson. Let's continue on. If you're still with me, you're doing great. Follow along and then go ahead and do some experiments and even search for LINQ Visual Basic examples online or on Microsoft.com. Okay? So we'll see you in the next lesson. Thanks.